Welcome everyone. The question is two lamps, one rated 100 watt 220 volt. Another one is rated 60 watt 220 volt are connected in parallel with the electric mains supply. What current is drawn from the line if the supply voltage is 220 volt? Obviously the supply is an AC one. But since the supply voltage is 220 volt, we should not use this type of um, battery or cell, but considering that 220 volt is constant throughout the time of operation, we just assume it is constant. That's why I have used this battery, but actually battery is not used as a supply voltage in case of the electric mains supply. Okay, but what is the purpose of considering? I have clarified first. Okay, 100 watt 220 volt, 100 watt 220 volt. It is basically the specification of the bulb 1 which is given. So its power is given, its voltage is given. That means what is the maximum power it can dissipate if it is connected to the 220 volt, it is given. Obviously if it is connected to the 220 volt, then it can dissipate or it can generate 100 joule energy. Once again, this information basically says this. So this information basically gives you that idea that P1 is equal to 100 watt and V1 is equal to 220 volt. Okay, so what is the expression of the power? P equal to V1 square divided by R1. Now what is R1? The R1 is basically equal to V1 square divided by P1. And what is this R1? R1 is the resistance of the filament of the bulb 1. And V1, I am just putting this value, that is 220 whole square. P1 is 100. Okay, so 22. Two zeros are already here, 100 is already here, and 22 into 4. 22 into 4 we can say, if you just calculate this, it will become 484. So it simply becomes 484 ohm. Okay. Now I can replace this bulb by a 484 ohm. If I do only the try to find it what is the current. Okay, so this is the thing. And what does it mean by another 60 watt 220 volt bulb which is considered as the bulb 2? So here the power is P2, that is 60 watt, and the voltage is V2, obviously same, so 220 0 volt. So P2 is equal to V2 square divided by R2, as R2 is the resistance of the bulb 2. So R2 is equal to V2 square divided by P2. So V2 is equal to 220 whole square. What is the value of P2? P2 is 60. So here it is 484 divided by 6. So 6 8 around 48. Okay, and after that 6 something. Okay, 80.6 something. Okay, so this is something 80 around. So what is the current drawn from the line if the supply voltage is 220 volt? So let us redraw this circuit. Here is one resistance 484, which is the resistance of the bulb 1, and here is another one resistance which is, we can say, that is the 80 something, we can consider as 80. Okay, and these two are connected in parallel, and this combination is connected to the 220 volt. I repeat again, 220 volt AC supply is not an DC. It is obviously the AC mains, but here I have considered that is the voltage 220 volt is remain same throughout this application. So I just put this EMF battery kind of source here. So what is the current passing through this? If I want to find it out, then I1, if I say this is my resistance R1, which is the resistance of the bulb 1, and this is my resistance R2, which is the resistance of the bulb 2. So I1 is the current through the resistance R1 and I2 is the current through the resistance R2. Then I1 is equal to 220 divided by 484, okay, voltage ohm, and I2 is 220 volt divided by 80 around. So very simply, obviously, since these two resistors are connected in parallel, so the potential drop across both of the resistors are same. So in that particular case, we just use this formula. So what is the ratio? Let me read the question. What current is drawn from the line? So you have to find it out. That means the I1 and I2 you have to calculate. So this is the current 220. You can simply